Hi, in this video I am going to explain about the K-nearest neighbor algorithm implementation in machine learning. K-nearest neighbor is a algorithm that assigns a new data point to class based on the majority class of its nearest neighbor in the feature space. Now we can see the example of K-nearest neighbor implementation. Here first we importing here pandas as PD library and import Seaborn as SNS and matplotlib pyplot as plt. This line imports the pyplot module from the matplot library which provides its MATLAB like plotting interface and Seaborn as SNS. Now I running this code. By running this code, the libraries are imported and now we read the dataset by using the read CSV function. Here I already select your dataset from my file manager and I copy the path of this file manager of this dataset and paste the path of my dataset here and run this. The dataset or reader and now we see the data pre-processing. Here I using head function to know the first 5 rows of our dataset and now using tail function to know the last 5 rows of our dataset. And then here data dot shape, it shows the columns and rows of our dataset and data dot is null function info function. This shows the type of our dataset and column names and so data dot is null function. It shows any null values or in our dataset. Here we printing the if any null values are there, all are zeros so that there are no null values. Here we importing the standard scalar from sklan dot pre-processing. Standard scalar is used for standardizing feature by removing the mean and scaling to unit variance and creates an instance of the standard scalar class and assigns it to the variable scalar. We will use this scalar object to standardize the feature later. Now fit the scalar to the feature of the data frame data by excluding the target column. The fit method computes the mean and standard deviation of the feature which will be used for scaling. Here applies the scaling transformation to the feature of data using the fitted scalar. The transform method standardizes the feature based on the computed mean and standard deviation. And then here creates a new data frame, data fit from the scaled feature. It uses the scaled feature array and set the column name to be the same as the original data frame data, excluding the last column target. The pd.dataframe function is used to create the data frame. Now data fit.add function, the first few rows of the data frame data fit, it helps us visualize the standardized future. This is the first 5 rows of the data frame of fit function. Now import the classification report and confusion matrix function from the metrics module of sklan. This function are used for evaluating classification model. And the line imports the kneighbor classifier class from the neighbor module of sklan. Kneighbors classifier is an implementation of the k-nearest neighbor algorithm for classification. First, we import the train test split function from sklan.model selection, and then we import the k-nearest neighbor classification. Here we importing the k-neighbor classifier for implementing the k-nearest neighbor algorithm. Now xtrain, xtest, ytrain, ytest split the standardized feature and the target column of the data frame data into training and testing set. The training consists of 70% of the data and the testing set consists of 30% of the data. The training feature are assigned to xtrain, testing features to xtest, training target to ytrain and testing target to ytest. X is a scaled feature, standardized feature and the target column of the data frame into training and testing set. And here the test size equal to 0.30. It's nothing but test or 70 and 30% or split here. Now creates an instance of the k neighbor classifier class with n equal to 1, which means it will consider the class of the nearest data point when making prediction. K neighbor equal to 1, it is the nearest point, data point. And then fit the k nearest neighbor classifier to the training data. It learns the relationship between the feature and the corresponding target label y train. And this line uses the trained classifier to predict the target label for the testing feature X test and store the value in prediction PRED named variable. Now I run this code. Here I show the prediction of our dataset. 0 and 1s are shows here. And then now this line print the confusion matrix and classification report, which provide evaluation metrics for the prediction made by the k nearest neighbor classifier. First, print the confusion matrix for y test and prediction. Y test, prediction. And then print classification report here for y test and prediction. By running this code, here is the classification report. Accuracy is 0.83 here. And now we can calculate error rate. For I in range of 1, 40 creates a loop that iterates from I equal to 1 to I equal to 39. For each iteration, it trains a k nearest neighbor classifier with n neighbor equal to I. And here makes prediction on the testing feature and calculate the error rate. The error rates are stored in the error rate list. Here mean the average of incorrect prediction calculates the error rate. By running this code, now we again train a k nearest neighbor classifier with n neighbor equal to 1. Again make prediction on the testing feature and print the confusion matrix and classification report for this model. Here the steps are same as follows. First we instance the kn neighbors and predict the x test and fit the x trait and y train, and then print the confusion matrix and classification report. The steps are same. So I here just paste that. Just here I named the prediction of I. Here we predict the prediction is for k equal to 1 for nearest to data point. For nearest to data point, we can conclude your classification report and confusion matrix. Now I run this code. Here is the output. The accuracy is 0.83. And now we predict the when k is equal to 10. This line, a k nearest neighbor classifier with n neighbor equal to 10. Make prediction on the testing future and print the confusion matrix and classification report for this model. Overall, changing the value of k and evaluating the model performance for different values is a common practice to find an appropriate balance between underfitting low k and overfitting high k in the k nearest neighbor algorithm. Here is k equal to 10. The accuracy is 0.3. For k equal to 1, underfitting low k and overfitting high k equal to when k equal to 10 in the k nearest neighbor algorithm. And now there is the implementation of k nearest algorithm. First importing library and data pre-processing, and then we check the null values and train the data set, and here implementing a k nearest neighbor algorithm. And here 0.83 is our first prediction accuracy score, and we find here underfitting for k equal to 1 0.83, and again we conclude a overfitting accuracy equal to 0.83. Thank you.